Hello, everyone, and welcome to the first session of our Open Pit webinar series. My name is Hajar Rahabat, and I'm a mining engineer in data mine software. I'm here with my colleague and also the co-organizer of today's session, Juan Pedro. Juan, we like to call him JP, and he is also a mining engineer in data mine software. We scheduled 35 minutes for today's session. And if you don't mind, we can leave the question up to the end, but please feel free to write down your question as we go in the question bar. Okay? Then let's start. For today, we will show you how to create your ultimate pit using our tool in our software NPVS. So, full life of mine project needs to follow these steps. The block model. So first of all, we need to prepare the block model, regularize it, and make sure that the block model has all the necessary information as grades, density, rock type, etc. Then add the economic parameters to the block model. So each block will have the processing cost, mining cost, revenue, and NPV. Then we can create our nested pits using the Lerche and Grossman algorithm. So we can finally choose our ultimate pit. When you have now your ultimate pit, then you can create your pushbacks and run your optimized schedule based on your targets and your mine constraints. So for today, we are going to focus on the first three steps in order to create our ultimate pit for this exercise. For this exercise, we have a golden copper block model. So for the input of the economic block model, we need the price of the gold and the copper, also the selling cost for both, mining cost, processing cost, and recovery, either rate or a formula. Then for your ultimate pit input, we need the discount rate, the annual rock out of mine, the minimum bottom width according to the equipment, and the slope region. For this block model, we have four regions. That is our rock type. That is the ore, soil, weathered rock, and fresh rock. Each of them has the slope angle according to the geotechnical reports of the mine. So now we can go to NPV and start our exercise. So this is NPV. And the first thing we are going to create our mine project. So in NPV, you can create a single mine project and multi-mine project. Or you can even open an existing one. For this case, we are going to create a new one. So let's give it a name. It will be my webinar, session number 1, and it's going to be on my database. So first of all, you can see on the project map that the same steps that we talk about, the economic model, your ultimate pit, your pushback, and your schedule, and you go accordingly. So in NPV, it's very easy to follow the steps as they are in a sequence. So the first thing, import your data, economic model, ultimate speed, pushback, etc. So the first thing we are going to do is to import our block model. Sorry. So let me bring my block model, that is golden copper block model. And then I want to import my fields. So first of all, we need to import our grades, that is my product, my lithology, that is what is ore and what is waste, and the density. For my slope angles, I'm going to use the zone. So the zone is exactly the same thing as litho, but zone here is numeric. I'm going to import these 5 fields and press OK. Okay, so you can see here we have the grades. That is the AU and CU. So it's the gold and copper. My lithology will be my rock type. My density will be density. And the zone will be my slope region. Okay, then we press next. So for the AU, that is gold, it's a grade, but for the copper, it's percentage. Then you put next. Okay, and here we go. Here you're going to tell the software what is ore and waste in your rock type. So for the ore is ore and the fresh rock is waste, the soil is waste, and the weather rock is waste as well. Also, as I said, the slope region here is the same as my rock type. So I know that my code number 1 is soil, and the code number 2 is my fresh rock. So I give it a label, the fresh rock, and number 3 is the weather rock, capital letter, and this is the ore. Okay, then I'm done with the setup. I'm importing, as you see, importing block model 87, 100%, and creating a surface information. Wait a bit. So now we are going to the economic block model. So I have all the information that I need in this spreadsheet. So for each ore, for the ore and the gold and copper, I have the price, the selling cost, the mining cost for each of them, processing cost, and also the recovery formula. This is for my economic inputs for this block model. So I'm going to use them on economic model under settings. We're going to create our economic block model. So you can create a model, like you create a cost model or a profit model. In this case, we are going to use a cost model for the price. We can add the price and add the method that we are going to use to calculate our cutoff. So for this case, we did the reblock of the block model. So we already defined what is ore and what is waste. So for that, I'm not going to take a lot of details discussing the method, but we have a method that is going to tell you that the rock type is specified as ore regardless of the grade. I will tick that and I will add the prices. So I will add them very quickly because I have them on the other screen. And here for the copper. Great. Now on my mining, mining setting, I can add dilution, the recovery, and the mining cost. So you can have it per ton or per cubic meter, so per mass or per value. Here on my ore, I can leave the mining cost like this and change the coefficient. So here we have like $5 to mine the ore. The weathered rock is $4. The soil is not very expensive, it's $3, and the fresh rock is 4.75. Okay, so I have all the information about my mining. Now, under my ore, I'm going to add my processing cost. So I will add the plant as my method of the processing and put parameters. So here I'm going to add the processing parameters very quickly. So the price or the processing cost is 36.91. So the recovery here, you can either a fraction or a formula. In this case, we said we have a formula that we're going to use for both. So for copper and for gold. So I'm going to copy this formula And I think some of you are familiar with these formulas. Okay? Then you can put on the CEO the same thing. The CU, not the CEO. And I have here in my Excel, okay, and copy this one as well. So I get my formula. I can even check the formula if it's correct or not, say okay. So now I have my processing cost and all my mining cost. Then I can say okay and run my economic model. So now I have my economic model that I can visualize. So now I have an economic model, and I can also export it to show it to you as block. So I can export the model and export my full block model with the economics. I've already done that, so for the sake of time, I'm going to open it on the other side. So this is my block model. So here it has all the information about my NPV, mining cost, processing cost, my destination, and also the NPV mass and the NPV volume. So if I'm going to open my original block model for you to see, so this is the original block model with just the zone and the lithology, the grades and the density. But now we have more fields and each block has this information. Okay? We can close it now and let's go back to our optimization. Now we are going to set our ultimate bid. So let's go back again to our spreadsheet that has all the information about our inputs. Okay, so we said that for the ultimate bid input, we need our discounting rate, our annual rock out of mine, minimum bottom width, and your slope region. Then I have a slope region depending on each one, and this is basically everything that we need for the ultimate bits. Okay, so let's go back again to NPV. So now under our ultimate bits, and we are going to add all these informations. So under settings, we are going to add our annual discounting, that is 14.5, our average ore tonnage or ore production per year. Under ultimate bid, we are going to choose, do we want to maximize our cash flow or maximize our resource? And here in the sequence, as we mentioned in the presentation, you can use or you can create the LG phases based on the profit factor, the price factor, or the mining cost. So you can see the influence of the price on your phases, on the volume of your bits, also the influence of your profit factor, and also the influence of your mining cost factors. Here also we already imported our slope region, that was our lithology. So here under soil, so the slope region for soil is 25 degrees. So I'm going to calculate to put 25 and take the best fit with the less error and say okay. For the fresh rock is 55 degrees. So parameters, I'm going to calculate and put 55 degrees of my slope region and choose the one with the less error or the smaller error. Weathered rock, the same thing, is 45 degrees and the ore is 55 degrees. It's correct. And then I can say yes. So here under option, you can put your initial topography if you have it. So we can import it in from data mine surface, and then you have your pit limits that you can, for example, you can create a boundary that you don't want to exceed. If you have a river, if you have constraints, if you have like a village close to the mine, so you can put as a string, as a bit limit, and you will have it as your limitation. Then you can generate your final bit with a minimum bottom. It's according to your equipment and the size of your equipment. Then I can say OK. So I'm going to run my ultimate bit. So when you run your ultimate bit, it's going to take from 4 to 8 minutes. It depends on the size of your block model. If you have a bigger block model, it will take more. So I have already done or run it on my own, so you can see it here in this project. So this is the one that I have done with the same parameters. This is your report. So you have a report with incremental data and you have a report with cumulative data. So basically in the report you have your phase code. So this is the code of the bit. The factor, so this one is, for example, 2% of your revenue factor. You have the ROC, the revenue, your processing cost, your mining cost, your NPV, your ore. Here you can see that we have ore that was now it's waste. So it was categorized as ore, but now it's not economic enough to send to the plant, so it's sent to the dump as waste. So whether the rock is waste, soil, fresh rock. Also, you have the grades and the tonnage of the Cu and the copper and the gold. Also, the recovered grams and the recovered tons. Okay, so I want to visualize this data. So I can go here, visualize my algae phases, and I want to see all phases. Okay, so surface file loaded, and it's bringing them. So here I can see pit 1, 2, 3, and then I can see my pits going bigger with the revenue, with bigger revenue factor. Can get to 100% revenue factor until I get to 200% of the revenue factor. So I saw now my pits. Now I want to make the data talks. So how am I going to do that? I'm going to copy and I'm going to Excel. I'm going to use an Excel. So there is my book. So basically it's very straightforward. I'm going to add another field here that we'll call total waste because I want the sum of all of this waste. So it's the sum of the ore that is waste now, weathered rock, soil, and fresh rock. And now I can select this data and insert a pivot table. And I want to visualize my factor in the rows. And I want to see my NPV, my ore, and my total waste. Quickly make them as a sum value. And make them like this. Now I can create a pivot table quickly with my NPV, that's going to be my lines, and the waste and the tonnage. So basically, and very quickly, we have created our optimization chart. So we can visualize our bits. So this is the ore and the waste and the NPV according to each one of them. We can see that the NPV is stabilized here. So the difference between this bit and that bit is the life of the mine. So here it's come to the same NPV or close NPV, but with highest life of mine. Here it's depend on the company, it's depend on the mine. Is the strategy is to keep a long life of the mine, or you just want the highest NPV with less or with a short period. So basically, we can pick couple of these bits that they are remarkable, and then we can make a comparison between them. So I have already an existing one that I want to show you here. So basically the same data, but this one with a much nice color. So you can see here, this is the same chart. This is with the NPV. Then you can see that here you have remarkable pitches. It's like a jump from one pit to another, and also a jump of the NPV. Then you can see that the NPV is dropping here, so you can see the difference. Then you can put them aligned with the strip ratio and the ore tonnage and all the information. Then you can compare them. First, to pick or to choose your ultimate bid, but also to analyze these bids, and maybe you can use some of them as pushback. Okay? So basically now we will see the highest NPV, that is 1.02. So if we're going back to the database and 10 and the bits 1.02, that is 102% of the revenue factor, you can find it here. So 1.2 is basically the code number 51. So if I want to visualize just this bit, so I can come again to visualize and my LG phases and put my 51. So my code number 51. So I just want to see this one. And here we go. So this can be my ultimate bit. I can export it to OP, visualize it, then I can design it, etc. Okay? So basically this is my ultimate bit, and if you stick on the next session, you're going to see how to design the pit on OP and go back again to create your pushbacks. Okay? Okay, so now we have our base case, but we all know that the risk analysis is very important for our pit, for our mine. So either you need to bring investors, or you need to convince your existing investors to go with this project. So we need to have information if the price go high or low, and we don't want to be in problem if the price is dropping. Also, it's good for us if the price is higher. So instead of doing all of this process all over again, adding information manually one by one, so you can come here on your projects map and then you can create a new setting. So for example, will be your ultimate bid, and it will be, for example, the price is 10% higher. Okay? Higher, let me. Mhm. Okay, so my ultimate bid is, it's all wrong. Ultimate bid, and my price is 10% higher. Perfect. And then I'm going to add it. It's basically very easy. Copying the settings and paste them. Double click on here and I can see on my optimization that the setting is here. Then I can change my price to be 10% higher. So for example, it would be 45%, $45. So I can do, and I can run my economic model. This will be quick to run. Then I can double click on my ultimate bid, setting, copy, and do the same and paste. So now I have the information on my ultimate bid as well. So instead of doing like 10% higher, 10% lower, 5% higher, 5% lower, I can add them like this very quickly. Then I can run them all together. So I can have this one and setting and case study, and I want to add to batch. So include case descendant, I want to say yes. So I want to run the economic model, then the ultimate speed, then the pushback. Because I have nothing here, so it's not going to calculate anything for me. And I'm going to do the same for the settings. And I'm going to do add to batch, include case descendants, yes. So now I will have to do it for 5 or 4 once. Then I'm going to run my batch. So here under tools, I can say empty the batch, or I want to see the batch, or I want to process the batch. So I can create like 5 or 6 scenarios, add them to the batch, process batch, go for a coffee, do something else. Then I have like six coffees, six six scenarios in one side. Okay, so let's say that I have these scenarios and we did the same. We take it to Excel to create our shells and to our charts. So here you can see the sensitivity analysis of the price. So this is my base price. So if the price is 10% higher, if the price is 10% lower, 20% higher and 20% lower, then you can see your ultimate bid and analyze the risk if the price is lower and the profit if the price gets higher. Okay, so it's basically very straightforward and easy to process and also easy to create this sensitivity analysis. You can add it for price, for revenue, for cost, for any cost that you want to run the sensitivity analysis on it. So here we go. Okay, so now we run our NPV scheduler. We did we imported our block model, our economic model, and we created our ultimate bid that we choose. After analyzing the data, we ran a sensitivity analysis, and we saw how it was quick and easy to manipulate and to visualize the data as well. We get to the end of our session today. If you have any question, please raise your hand, and I will be reading the question from the question bar. Thank you very much for your attention.